Welcome to Constellations, the podcast from Kratos, where industry leaders share their thoughts and experience on the future of space business, policy, and opportunity. If you like Constellations, please support us by giving a rating and review on iTunes. And don't forget to share this podcast online to help our community grow.
Welcome to Constellations, the podcast from Kratos. My name is John Gilroy, and I'll be your moderator. Our guest today is Ryan Lewis, Senior Vice President and Lab Director, In-Q-Tel. Today, we will discuss how rapid advances in analytics technologies are shaping the broader developments in the commercial space and aerospace markets. New technologies such as artificial intelligence techniques like computer vision offer new ways to process and analyze the growing volume of remote sensing data from both incumbent technology providers and new venture-backed startups. In this podcast, find out how the commercial space and aerospace markets have evolved over the last several years and how emerging geospatial analytics applications could change how these products and services are used by public and private sector organizations alike. Our guest today, right in front of me, Ryan Lewis, Senior Vice President and Lab Director at In-Q-Tel. He co-founded and leads CosmiQ Works, an applied research lab within IQT, developing machine learning algorithms, open source tools, and curated remote sensing data sets for geospatial applications such as foundational mapping. Ryan also co-founded and serves as general manager for SpaceNet LLC, a nonprofit organization dedicated to accelerating open source geospatial analytics, which is run in collaboration with several partners including Maxar, Amazon, Intel, Capella Space, Topcoder, and the folks from IEEE GRSS. Well, Ryan, it's a very mysterious name here, In-Q-Tel. How did that come about? What do they do?
Well, first of all, I wanted to say thanks for having me on the show, and thanks to Kratos. It's good to be on the other side of the mic. To kind of start from the top, what is In-Q-Tel, and then where does CosmiQ fit into that? You know, In-Q-Tel is a strategic investor for the U.S. national security community, and we've actually crossed a major milestone for us. It was our 20th anniversary this past year in terms of working with both the national security partners as well as venture-backed startups from across the country. From the lab's perspective, CosmiQ Works is one of In-Q-Tel's applied research labs that focuses on different aspects of artificial intelligence. Specifically, my group focuses on geospatial analytics, as you said in the opening. And it's something that we have been targeting for the last 5 years, and our work has evolved greatly in that time from just preliminary research to essentially building whole open source models that work across a variety of data sets.
You know, if you're listening to this and it's 90 degrees outside or something in the summer, and you want to find out more, it's spelled CosmiQ Works, right?
Correct.
Good. Because I know it's going to happen. People listen to this in a podcast and they're running or something, trying to figure it out.
People should look at the website at least once a week. I highly encourage it. Yeah. It's just an opinion.
You know, a key challenge for the government is getting access to cutting-edge technology in the commercial sector in a timely manner so they can apply it. So how is your organization helping our govies with this problem?
Yeah, you know, In-Q-Tel was founded with that focus in mind specifically. You know, if you look back into the late 1990s, accessing emerging technologies in Silicon Valley was really challenging, particularly if you look at it through the lens of traditional acquisition systems across the government. And so, as a firm, we have really taken our strategic goal of accelerating access, pilots, and adoptions to commercial-based venture-backed startups across the country, across all different types of technology areas, so ranging from software to hardware products. And one of the core ways that we do this is working on an annual basis with our different government partners, venture-backed companies, and their investors to target what we would call technical work programs. These work programs are specifically designed to help companies that we've invested in get over those initial hurdles to accelerate piloting and adoption by our different government partners. Now, this is a little bit different on the lab side. Because our work, for the most part, is operating primarily in the open source, which we'll talk more about later. But if you think about most of the rapid developments in the AI domain, really in the last 5 years, and kind of one of the benchmarks that we use in the computer vision space is when Google open sourced TensorFlow in November of 2015. ever since then, a lot of the work, at least from an applied perspective, that different end users want to get access to for either doing early prototyping or even maybe building out a minimum viable product for testing, a lot of that starts in the open domain. And so whether it's CosmiQ or some of our other labs, we've really tried to focus on building out either open source data sets or tools to help our government partners as well as commercial companies get started with some of these really advanced technologies.
I think we're finding that innovation doesn't reside in a zip code or a geographic area. It's all over the place. And I guess it's a possibility that these new technologies have had some kind of a democratizing effect on broader access to public and private organizations. So how does that affect your efforts?
Yeah, it's arguably one of the most exciting things that I've had to experience really in my time at In-Q-Tel and specifically with CosmiQ, in the sense that whether you're talking about more traditional space systems, such as either small satellites or software companies that are focusing exclusively at the applications level, what makes the democratization effect really compelling is that it opens the aperture to either companies or individuals that are contributing either to code or to company ideas. So long story short, what that really means is you have a lot more either new starts from companies or interest from investors that simply expands interest in a domain, in this case space, that was historically somewhat niche in terms of those providing products and services to it, just given the technical complexity. And that's been really exciting in terms of having new people come in with new ideas and sort of changing in some ways how both the commercial space and now sort of aerospace industry think about delivering products and services, particularly at the software level.
I'm glad you used the word aperture. It's real popular with this audience.
Yes.
It should be. Let's take a look maybe at the investment side. The space industry has transformed rapidly with lower cost infrastructure, multi-constellations, and more capable satellites. Now, how have these changed your investment strategy in the space aerospace market?
Yeah, the story of how we started investing in sort of the commercial aerospace domain is kind of a neat one, and it's one that I wish I could say I could take a majority of the credit for, but that would be incorrect. Really, a lot of the work goes out to some of our partners, including on the investment side, including Tom Gillespie. And essentially what we did about 5 years ago is we said, all right, we're seeing sort of changes across the entire market. So this is ranging from all the way from access to launch vehicles all the way to the top at the application space. And we're having so many new starts, as we were just talking about, from a variety of different companies. How do we assess this from an investment perspective? In other words, how do we put all the pieces together to build a cogent investment strategy? And this is something that you can find on our website under the resources. We built what is now called sort of our investment architecture or technical framework. And this is, in some ways, it's just a way to arrange different technical offerings and see how they connect together. But at a strategic level, it allows us to look and say, are we making sufficient amount of investments? Do we have sufficient amount of awareness in different aspects of that stack? And over the years, since as companies mature, or as we've seen in other cases, more money enters into the market for different types of companies, we've modified our strategy over the time. So imagine going back to 2014, a lot of our initial focus was just trying to understand what was happening in the market. Who are the new starts? Who are the relevant players? What does this mean from a broader supply chain base perspective? To today, that looks very different as companies have now matured, and we're now more focused on the utility of the products that they're delivering. So if you're a company that's building a remote sensing constellation, it's much less on let's look at the satellites or talk about different orbits that you're thinking about working in, and now much more on show us some of the data, show me some of your early products, and tell me where you see some of your product line evolving to in the coming years based on feedback from either early customers or thoughts from your engineering team based on the experiences they had.
So I know the market's probably a little more mature than in 2014. So you cast out the net, and you reel in a couple of fish you think are pretty good. So now what? And how do you measure them? How do you measure their success or your successful efforts with them?
Yeah, there's a couple different ways to do it. And I think at the general level, one of the ways to sort of measure success is just to see how have companies delivered against their strategies. And so we've seen a lot of, I remember, early days, I remember going back and people talking about all the different sort of coverages we were going to have from imagery or other types of remote sensing platforms. And there was arguably some hype around that. What I think has proven very useful for us is now to go back and say, all right, how long did it actually take to deliver some of these assets? Because even though we've seen a rapid commoditization in the space and aerospace domain, it's still really hard. Elon Musk's quote is accurate. And as a result, that means that some of the timelines may have slipped. That's not necessarily an indictment on anyone in the company. It's much more of highlighting how difficult it is to go from an early prototype to a full service solution that companies build and maintain and customers can really leverage. I think for us, as we look out into the next couple of years, what we're really watching for now is how does customer demand grow based on the availability of these services.
Ryan, thousands of people from all over the world have listened to this podcast. If you're listening now, go to Google and type in Constellations Podcast. You'll arrive at our show notes page, and it'll give you free access to transcripts, and we can send you email notifications of future shows if you wish. Let's talk a little more about open source here. When you look at open source applied research, what motivated you and the team to start CosmiQ and begin open source applied research specific to geospatial analytics?
One of the big motivators for us was actually looking at what was the foundation of a lot of the early computer vision research in the community. And this is not necessarily for geospatial analytics or anything to that effect. So if you look at a lot of the early papers that were focused on computer vision, most of them were working on a data set called ImageNet. It's been well documented now, but essentially all the images of cats and dogs and things like that. And it's critical. Most of these models started with scene classification on simple things like that. And just seeing the impact that data set and then all the research that came from it had on the broader computer vision research community, we said, that is massive, but do we see analogs to that in the geospatial market? Because in some ways, you can certainly transfer a lot of the work that's been done in just the broader computer vision field to different types of remote sensing data sets, no doubt. And a lot of companies have and done really interesting work. But there are natural limits to it because, as you might guess, simply looking at a photo that you've taken, for example, taking a photo of us in the studio today, that's a lot different than saying, hey, are there people in this or not, to then saying, find me all the different building footprints at this level of accuracy in a satellite image. Those are fundamentally different problems. And at some point, you need to address those directly, both from an analytic perspective as well as a software perspective. And so that was really our motivation to say, we should be focused on this community to help transition or essentially overcome that gap between what we see in the current research community now and applying it to more geospatially focused problems.
When you said ImageNet, I wrote an arrow and I said, well, this is going to lead to Skynet. But it didn't.
Hopefully not.
Hopefully not. Talking about open source applied research again. So why do you think it's so important to the wider aerospace industry?
Because it's a great question. It's one that actually comes up a lot. I think really the simplest way to answer it is that the work that is occurring just more generally across a variety of different AI applications, the level of just product development and acceleration is really unprecedented in the open source domain. This is something that it's still hard for me to believe at times. And what I mean by that is it's a wealth of resources for either companies or governments to get started with their early projects. And it is a resource probably going forward for companies to leverage as they're figuring out how to build their products. And the reason to emphasize it is that this is something that is new when you think about how to build out analytic products, essentially starting with something that's out in the open and then tailoring it for perhaps a proprietary purpose is somewhat new in this industry. And that's why we really wanted to not just prioritize it, but provide almost as a trusted resource for researchers to get started. And what I mean by that specifically is writing rigorous analytic baselines on how we've seen certain models perform, writing sort of detailed analyses on our blog, which you can find through our website, essentially highlighting what we think is sufficient for certain projects and so on and so forth. We really wanted it to serve as a starting place for companies and researchers when they're thinking about getting into advanced analytics in the geospatial domain.
How have you seen the space, aerospace, and geospatial analytics sector evolve? What does that change mean for the market going forward?
Yeah, I think it's easy to get lost in all the excitement about the sector. And one of the best ways sometimes to make sense of all this interest and momentum is to ground yourself in sort of a set strategy. And one of the things that we've done as a team, both on the CosmiQ side as well as on the broader In-Q-Tel side, is to sort of set a basic strategy and target our projects towards that. If you think about some of the early claims in the geospatial domain, we started with a real simple question, which is what effect does, example for this in this case, what effect does resolution have on model performance? So from that, you can look at just analyzing inputs from the data set, so resolution, look angle, and then you can look at it from the model perspective. How well do different models perform? Is there a difference? Essentially, building iteratively across that strategy has been critical for us. And so it may not always be the most thrilling to say you're going to test something for the 6th or 7th time. I know I've had more than my share of headaches sometimes retesting, but I can tell you for us it has been, I would argue, a major success for us to take an iterative approach, which then other people can use and say, these guys have looked at either this data set or this model, tested it rigorously, so I know I can trust these results, whether I'm building a product or I'm expanding upon their research for some other effort.
You know, you're thrown into this world of Python and R and huge data sets and big data and geospatial information, and it's kind of hard to figure out where to start. And I think you're focusing in on tractable results. Is that right?
That is our intent.
So what are some of the major findings or results you've uncovered in the past few years?
You know, if we've as I mentioned, so we've tried to look systematically at all the different aspects of the machine learning workflow, from data set requirements to model testing to how you go about labeling, right? And as an example, just as an example, something that's easy, I think, to interpret is if you look at the difference between our two different SpaceNet challenges. So our first SpaceNet challenge used a data set that was a 50-centimeter ground sample distance. That's a type of resolution, mosaic. And then SpaceNet 2 used a 30-centimeter GSD, or ground sample distance. And simply the difference in resolution alone had a substantial impact on how almost the same type of models performed in identifying building footprints. Now, to all of us in the room or listening, that may sound really obvious, and in some ways it is. But I think what's substantial or what's significant about that is not that we proved out something that is perhaps sort of logically coherent, but that we can begin to quantify these results in ways that provide deeper insights into how we want to tune models or how we want to leverage different data sets. Now, that was for a specific example. One could argue that it would change drastically between applications, but I think that was a really interesting finding that really jump-started a lot of additional work, both in SpaceNet and some of our broader CosmiQ applied research projects.
Early in this podcast, we talked about CosmiQ Works and SpaceNet. Maybe you just kind of talked about states. Maybe you could define this for our audience. So complete different organizations, right? So tell us about SpaceNet.
Yeah, so SpaceNet is one of the efforts, and arguably it's the most primary effort that the CosmiQ participates in. And specifically, as you mentioned in the open, it's a nonprofit LLC, and we run it in collaboration with all the different organizations that you mentioned. And in the beginning, we started it very informally as a collaboration effort between us and Maxar. At that time, it was Digital Globe. And the early effort was, kind of going back to that ImageNet example, was just to see, can we get data sets out there, and how, essentially, is there a lot of interest in them? And if we host a public data science challenge, what type of results will we get? And given the level of interest that we got from just the open source community and the results that we saw, we all kind of collectively agreed there was a there. And it's something that over the last 3 years we've worked to expand, and proud to say that next month, or really in early March, I should say, we'll be launching our 6th SpaceNet Challenge. And we're particularly excited about this one because our first 5 really only focused on electro-optical imagery. And this is our first multimodal challenge, which will include both high-resolution electro-optical as well as high-resolution synthetic aperture radar.
I think you're almost making it fun. If the goal is accelerating geospatial machine learning, that seems like a kind of a boring class to take in a classroom or something. But if there's a challenge in different teams across the country working on, all of a sudden innovation comes in and people try to be creative and new ways to do it because they want to beat that other team in the state of Washington or California or Florida. So it's almost a gamification of the system, or making it fun, and really a lot of results come from that, don't they?
Yeah, I mean, to your first point, everyone should think that geospatial analytics are fun. And if people aren't if people aren't doing that on the weekend, that raises concerns on my part. But we'll talk about that later on. No, it's been really surprising and exciting to see the different responses from across the world from all the different challenges. We've hosted 5 to date. We've had over 1,300 responses or submissions on the challenge site that we use, and one of our partners, which is Topcoder. And it's what I really enjoy is that as we've become more mature, we started to have repeat participants across the challenges that look forward to when we release something. They ask us when something new is going to come out. And so I'm excited to see what they produce when we launch 6, which is arguably going to be our hardest challenge yet.
Competition always brings out the best in people, doesn't it?
It does.
It really does. Well, if the goal is to accelerate adoption of innovative technologies for the geospatial market, I think you got some notches on your belt. I think you've accomplished some of that. So what do you think is in the future for CosmiQ and SpaceNet in 2020 and beyond?
On the Cosmic side, I think one of the things that we've worked on since the beginning, kind of going back to the strategy part, is prototyping what we think the geospatial analytics workflow of the future is going to look like. And there's a lot of other groups that are working on that or different aspects of it. I think for us, we want to continue to do that. And specifically, as new sort of analytic techniques come online, I think one of the big ones that certainly was getting a lot of interest at ICCV and CVPR in 2019 was something called domain adaptation. I think that has a lot of relevance in the geospatial world, and that's something that we want to explore and benchmark rigorously, as we've done in different resolution studies and look angle studies in the past. On the SpaceNet side, our goal is to not only build 2 different data sets, but launch 2 different challenges each year. So we're planning for SpaceNet 6 in March, and our goal would then be to hopefully target the launch of SpaceNet 7 in the late fall, early winter of this year.
So you're kind of matching the rapid evolution in technology and ways to handle that out, aren't you?
You bet. I mean, and what's cool is once you have a lot of interest from the commercial and research community, it almost starts driving itself in some ways. And so for us, with the data set alone, it's just been downloaded millions of times. And so you start getting insights from different end users about what they would like to see next.
I didn't realize that's the number, millions of times. Really?
Yeah.
That's the amount of people all over the world interested in trying to manipulate this and manage this.
Millions of times, and as I checked last week, in 81 countries in some capacity. So going back to our comment about what people do for fun, apparently there's a lot of interest in geospatial, and in all seriousness, I think it highlights in the classic dichotomy that we see in the analytics world. On the one hand, it is accelerating immaturity far beyond, I think, what anyone really predicted in terms of capabilities and prototypes and things like that. And then on the other hand, you have still just a very basic interest in getting access to quality data. And so for us, we hope that projects like this help feed both those needs, both for the early researcher as well as the venture-backed company that's building cutting-edge products for both public and private sector markets.
That's wonderful. Ryan, unfortunately, we're running out of time. I'd like to thank our guest, Ryan Lewis, Senior Vice President, Lab Director, In-Q-Tel.
Thanks for having me.
Thanks for listening to Constellations, the podcast from Kratos. If you like this interview, please subscribe, tell a friend, and give us a review.